Good day, everyone. In this experiment, we will discuss the gradation of aggregates through sieve analysis. This activity is one of the most important laboratory procedures in construction materials testing because aggregates greatly affect the strength, durability, and quality of concrete. Aggregates are classified into two main types: fine aggregates, which are commonly sand, and coarse aggregates, which are commonly gravel. These materials occupy a large portion of concrete volume, making their proper grading essential in construction projects. The main objective of this experiment is to determine the different grades of aggregates by analyzing their particle size distribution using standard sieves. Through this process, we can identify whether the aggregates meet the required specifications for engineering applications. In this video, we will show the materials used, the step-by-step procedure, the testing process, and the significance of proper aggregate gradation in construction engineering. The objectives of this experiment are to determine the different grades of aggregates and to understand how particle sizes are distributed in fine and coarse aggregates. At the end of the activity, the students should be able to identify and classify aggregate sizes using sieve analysis. The experiment also helps expand knowledge regarding aggregate grading and its importance in other construction material tests. Furthermore, this activity develops practical laboratory skills that can be applied in professional engineering practice, especially in concrete mix design, quality control, and construction testing procedures. Aggregate gradation refers to the distribution of particle sizes within an aggregate sample. Proper gradation is important because it improves packing density, reduces the amount of voids, and creates stronger bonding between cement paste and aggregates. When aggregates are well graded, the smaller particles fill the spaces between larger particles. This results in denser and stronger concrete with better durability and workability. In this experiment, sieve analysis was performed using standard sieves with different opening sizes. Fine aggregates and coarse aggregates were tested separately to evaluate their grading characteristics. The sieves were arranged according to size, with the largest opening placed at the top and the smallest at the bottom. The aggregate sample was placed in the top sieve and subjected to vibration using a vibrating stand for several minutes. As the sieves vibrated, the particles were separated according to size. Larger particles remained on the upper sieves, while smaller particles passed through lower sieves. After the sieving process, the retained materials in each sieve were weighed carefully using a digital weighing scale. The measurements were then compared with the original sample weight to determine the gradation and percentage error. This procedure demonstrates the importance of precision and accuracy in laboratory testing because even small errors can affect the quality of construction materials used in actual engineering projects. The materials used in this experiment include gravel and sand as the aggregate samples. The equipment used includes sieving instruments for fine aggregates and coarse aggregates, a vibrating stand, a weighing scale, and a digital weighing scale. Each piece of equipment plays an important role in ensuring accurate and reliable test results. The sieves are responsible for separating the aggregates into different sizes, while the vibrating stand helps improve the efficiency and consistency of the sieving process. The digital weighing scale is used to obtain accurate measurements before and after sieving. Next, the sieves for fine aggregates are arranged according to their grading sizes. The sieve with the largest opening is placed at the top, while the smallest opening is placed at the bottom. The sand sample is then poured into the top sieve. Afterward, the sieve assembly is placed on the vibrating stand. The vibrating stand is operated for several minutes to allow the sand particles to pass through the sieves and separate according to size. After the vibration process is completed, the retained sand on each sieve is collected and weighed individually. These measurements represent the final weights of the graded sand particles. The total graded sand is then computed and the percentage error between the initial and final weights is determined. The same procedure is repeated for gravel, using the sieving instrument intended for coarse aggregates. During the experiment, careful handling of the sieves and accurate measurements are necessary to avoid loss of materials and incorrect results. Proper recording of data is also important because the gathered information will be used to analyze the grading characteristics of the aggregates. In conclusion, this experiment provided a practical understanding of aggregate gradation through sieve analysis. By separating fine and coarse aggregates using standard sieves and a vibrating stand, the group was able to observe the distribution of particle sizes in the samples. The experiment highlighted the importance of proper gradation in achieving better compaction, strength, and durability of construction materials. The activity also emphasized the value of accuracy, proper testing procedures, and correct handling of laboratory equipment. Overall, the knowledge and skills gained from this experiment can be applied in concrete mix design, asphalt production, quality control, and professional engineering practice. Thank you for watching.